Without further ado, our first session for today is a keynote interview with Faisal Siddiqi, Director of Engineering for Personalization Infrastructure at Netflix. I'd like to welcome Faisal up.
Hey, Sam. Good
Hey,
to talk to
Faisal. How you doing? Great to
I'm
see
doing
you.
great.
Welcome to TWIMLcon.
Excited to be here.
I want to send a quick note out to folks that yesterday in the session we had both a chat and a Q&A, and today we're going to have all the questions posted in the chat. I'll be taking questions and sharing them with Faisal during the session, so be sure to get them in. Faisal, let's start with having you share a little bit about the team that you lead at Netflix and how that team came to be. What's your story?
Yeah. So I joined Netflix about 6 years ago in early 2015, right around the cusp of what I would call was the confluence of big data meeting machine learning. And it was a time well before TensorFlow, PyTorch, and XGBoost were household names, or at least in our industry. But the sort of the ML models' hunger for data was starting to become evident. As you know, Netflix is quite well known for the use of machine learning for their recommender systems, going all the way back to the Netflix Prize back in around 2008, I think, when we basically released some of our user ratings and challenged folks to come up with an improvement to our algorithm to predict those ratings. And over time, certainly we kept investing in that. But by the time 2015 came around, Netflix had about, I'd say, 60 million global members in about 30 countries. We were preparing to go global all over the world the following year. Our forays into original content were still pretty new, a couple of years old, but the streaming engagement that we were seeing was basically pointing to a future that would fast outpace the engineering systems built around our recommender system. So it's around that time they brought me on board to leverage some of my experience with distributed system technologies like Spark and others, and sort of build a scalable ML platform for the recommendation systems. Our initial focus was very much on sort of like key areas like training data infrastructure and orchestration of ML pipelines. But over the past 6 years, the personalization infrastructure team has grown to touch almost all facets of machine learning and partners really closely with practitioners to enable product innovation. I'd say our platform is a loosely coupled entity of composable building blocks. There's often a trade-off for a platform developer on where on the spectrum of standardization and flexibility you need to be. We feel that we're at the right point in the spectrum where we can be opinionated, but not be limiting. So we are we have a way in terms of how our platform standardizes key engineering choices around facts and feature definitions and transformations and management, but at the same time gives researchers the flexibility on choosing how models are assembled and put together and which framework that they would use for. So that's pretty much what we've been doing. Our teams have grown 5x in these 6 years. I'm super proud of the amazing talent we have. And those are some of the things that really excite me to come to work every day.
That's awesome. You mentioned the impact of personalization and recommendations at Netflix. I remember, I forget the year, but there was a note in a research paper that quoted the impact at this time, and this was years ago, at like $1 billion or something. It was it was a ridiculous number at the time. Do you remember what I'm referring to?
Yeah, I know that paper very well. This was something that was written by some of our leaders, and then it's essentially a technical white paper, and they were making a case for why the personalization recommendation systems bring in well over $1 billion worth of meaningful impact to the company, and describe the various personalization facets that we employ. I mean, almost everything that you see on the Netflix homepage is personalized and is backed by an ML model, back from sort of the core catalog ranking. So every every title essentially is ranked for every active member profile in the system multiple times a day. The whole homepage is different rows that appear on your page are powered by an ML model. What imagery and artwork we'll use for that particular context for that particular user is employing machine learning. So it's incredibly useful. It's incredibly impactful to the company. So yeah, I mean the dollar amount, obviously, I'm sure has changed over time as our member base has grown. But the fact is that it is critical to enabling people discover sort of what we call moments of joy when they discover a show that they really enjoy.
Who are the constituents that your team serves at Netflix?
Yeah, so that's actually a great question, because it's one of the things that is really important to understand your key consumers well. And there are essentially what I would characterize as 3 different sets of ML practitioners that we serve. One is what we internally call as algorithm engineers. And these are people who are trained in both software engineering design principles, but also have a good understanding of machine learning. They are capable of sort of taking a good idea, exploring it, but then also productizing it. And then there are ML researchers who are sort of exploring new cutting edge techniques in terms of how the evolving space can be leveraged for impacting product experiences that we can develop. And then there's data scientists who are oftentimes using some of these similar technologies, but their application is in the context of decision support. So for instance, to make a decision of which content should Netflix invest in. And these 3, and there's some overlap between the 3, and different organizations may not have exactly the same names, but I'm sure people will be familiar with the kind of skill sets that I'm talking about that these stakeholders have. And it's really important for an ML platform developer and teams to really understand the core strengths of those users and sort of play to their strengths. So for instance, for the algorithm engineers, it's really important that the solutions that we provide give them the flexibility and provide them the right API abstractions so that they can play as best as they can. And we respect their understanding of software engineering systems, and so we play to that. On the other hand, for some of the data scientists who really want to solve a particular problem, and oftentimes their application doesn't really even get to the end user. Remember, it's more for making good business decisions. We really need to understand how we can provide solutions that sort of go and meet them where they are. So providing simple to use Python-based interfaces, for instance, which that may be something that they're more familiar with. So yeah, so those are the sort of the 3 main user sets. I'd say in our org, traditionally, the algorithm engineers have been the biggest user of the infrastructure that we've built, but that's evolving over time and expanding.
So you've already spoken to this a couple of times, but one of the issues that platform teams really struggle with is how opinionated to be versus how flexible to be and how prescriptive to be. Sounds like you try to be on the flexible side of the spectrum, but can you elaborate a little bit more on the perspective you take there and how that plays out for your team and the teams you support?
Yeah, and I would say that we're flexible on some dimensions, and we're very opinionated on others.
Okay.
And that's exactly the trade-off that I'm talking about. So, for instance, and part of it is actually also derived from the Netflix culture of highly aligned and loosely coupled, where we want to give the teams the freedom to explore when they want, but at the same time make sure that they're highly aligned. So I'll give you some examples on where being opinionated has helped us. So, for instance, we've built a fact store, and this fact we define fact as basically largely invariant actions or user behaviors. So, for instance, somebody played a video or somebody added a title to their My List. These are sort of facts, and you transform one or more facts and put together, and you create features, and then you transform features, and so on and so forth. Now, the whole process of how you do that could be done in 3-4 different ways, and it used to be done in different ways. People would access data from whichever microservice that they wanted to, but that resulted in tremendous inefficiencies when you were sharing things across experiments or across algorithm areas. And so we really tried to standardize how all the facts are accessed in a store, provide a unified, scalable query interface for all the facts. So essentially, it's straightforward, regardless of the kind of facts that you're accessing, to get some of these. And it enables sharing a lot more easier. And we said, this is the way to do it. And then we provided building blocks to enable feature encoding, feature transformations, feature management, and all of these things. We don't really feel need the degree of flexibility, and they can benefit from one way of sort of doing it, so we can focus on higher sharing. On the other hand, where flexibility is key, is along the lines of, okay, how am I going to take all of the feature data, and I want to try 5 different network architectures, or I want to try 3 different ML frameworks to explore which of them is going to converge fastest and which of them is going to give the highest model accuracy. And therein we provide absolutely no restrictions in terms of how you can access that. There are good off ramps from our feature generation pipelines that you can then take into common standard third-party and open source data formats that you can then feed into things like TensorFlow and PyTorch and others. And then when you're back on doing model metrics and validations, there's also more opinionated stuff. So I would say the lowest parts of the infrastructure are definitely opinionated. And then as you go up, it's a mix of opinionation and opinion versus flexibility.
Mm-hmm.
And then when you sort of wrap up, that's where some opinion comes too. But ultimately, it boils down to, you want to give the most flexibility in places where there's potential for model improvement. And that's sort of the key guiding principle that we abide by.
It sounds like there's also a degree of maturity in a given area, and as an area matures, you build additional infrastructure so that folks don't have to reinvent the wheel. Is it a one-way street where?
No, you're absolutely right in that. And we have examples where we have certainly started out with, okay, well, here's a researcher who wants to do something. We don't know whether this is something that's going to be really broadly applicable. So we say, okay, go ahead and build something. And we have built something for them, sort of like a quick and dirty solution, or they have built it, and sort of we've partnered very closely. But then once we start seeing the utility of that and the broad applicability, we say, okay, you know what? Here's an opportunity for us to really standardize this. And we've done that at least a couple of times in terms of major projects that we've developed. So yeah, it evolves over time.
Do you find differences between supporting the research community and the engineering community?
Only in that, as long as your expectations of their skill sets are aligned with the reality, because we've made bad assumptions, and we are a fail fast culture. So we'll put something out there and we'll say, okay, we thought this is what you need, and you're going to go ahead and try the solution, but you realize that, okay, our expectations of what they are willing to spend their time on, some researchers, is not aligned with reality. And it means that we have to do a take 2 and a take 3. And right now we're going through a take 2 of a project, which is seeing a much better adoption compared to our last year's attempt. So yeah, there's certainly that is a key element in understanding what are the capabilities, how far somebody is going to do to get to a particular need, and we need to try to sort of make it as easy as possible without sort of losing the core value of what we provide.
This is a super interesting point you raised. We think a lot about the data scientists and the ML engineers needing to iterate quickly, but the platform teams do as well. And you've alluded to a few situations where you've had to iterate and take a couple of tries to get it right.
Oh, absolutely.
Examples of that kind of evolution in a piece of your platform?
Yeah, absolutely. So there was a case where we wanted to, as I mentioned that, or maybe I haven't. There's a case. So when we're trying to deploy machine learning into Netflix stack, the Netflix serving stack is all Java microservices, and so we've had to build systems that allow you to take your trained models, which are usually done offline, and then inject them into scoring and inferencing systems, which are running in Java microservices. And so to ensure that we don't have training serving skew, we have basically built a library, a Java-based library, which allows you to define your feature encoders, and then you essentially write it once during model development time, and then the exact same code is executed when you're doing scoring. And we also, with the fact store I mentioned earlier, we also ensure that it's the same data that's going into those features. So that's how we avoid training serving skew. And that's sort of a key underpinning of our platform. However, when we wanted to expose and open up our platform to some of the more data scientists who want to bring some of their learnings and research work into it, but perhaps don't have as much understanding of the JVM engineering ecosystem. So we said, okay, let's build out some wrappers on our services, and we'll expose certain data in Python APIs. We did that, and we gave them the access to the fact, and we said, hey, here's a REST endpoint where you can go ahead and you can make a service, and so you don't have to think about Java. And the fact is that the idea was great, but ultimately it didn't get adoption because, we had, they were like 10 steps away, and we had only come like 2 steps closer to them. And so what we had to do was to basically take the additional 4, 5, 6 more steps to say, okay, it's really more of a turnkey solution, and you stay in your notebook, and these are the clients that you can use. And essentially, this is a simple Python API that you have to expose, and you don't need to know anything, sort of abstract away something that's running behind. We still wanted to keep the invariance of the same code that you're executing in both training and serving time, but you basically need to build some higher order abstractions to meet to them. And that's the second iteration that we're going through right now in exposing our platform to other data scientists, and that's generated quite a bit of excitement.
Nice. So you've mentioned the platform several times here, and you provided a slide for us to show a little bit about the platform. This one has a lot of boxes, so a little bit difficult to talk through without the visual aid. So we've provided that to you, dear viewer. Faisal, I ask you to maybe walk us through the highlights here. But before we do that, I want to remind folks that are viewing that you can submit questions via the chat. And the way to get to the chat, if you don't see it, is to click on the Stream tab on the left-hand sidebar. That'll bring you to the same place, but there's a chat sidebar there where you can type in your question.
All right. So there's lots of stuff here. There's a whole alphabet soup here. So I won't get into the names and the meanings of all of those things. But the high level point here is essentially validating or demonstrating the point that I was making about a loosely coupled platform of composable building blocks. And this is sort of a 7-layer rainbow picture. The 7-layer, I picked that up because of my networking background, where the 7-layer OSI architecture is what I grew up learning with. But really, people will understand the function here, right? So each of these layers is a ML workflow function with training data preparation, feature engineering, training, model evaluation, inferencing, intent to treat, and treatment. And these boxes here show these various building block components that I've talked about. So there's everything from the fact stores to sort of discovery of content and access to the core abstraction that enable the definition of a feature, of transformations, of a model, to higher level ML APIs to sort of do the data preparation and assemble a model, selecting the right features together. There are tools for doing the ad hoc exploration and things like Polynode, which happens to be an open source solution. You can check it out on polynode.org. And it ties into some of the context that we are operating in. So Polynode, for instance, is a Scala Python notebook, and much of our algo engineers and researchers need to be in this hybrid world of JVM feature encoders, but also using some Python bindings for training and things like that. And there's as you go up higher in the stack here, we're building more differentiated ML services. So things like Hyperplane are about enabling more automation in various elements, hyperparameter tuning, or automating the sort of the deployment of models, so you can run continuous background automation test, scoring service that allows us to decouple the serving with the scoring, so you can throw heterogeneous compute resources, GPUs, and others behind when you really need to go after performance, model lifecycle management systems. And then sort of going into the actual services that serve the page is where serving and scoring happens. And there's a couple that I'd like to call out here: Algo Commons and Boson, which is sort of the workhorses of our platform. Algo Commons is sort of a Java library that provides all the building blocks of machine learning and is used extensively in personalization. And Boson is sort of a layer on top that provides high-level Scala ML APIs for each of these steps, actually. And then there's the orchestration systems that actually do the pipeline and dependency management. Dagobah is one of those tools that we use here. So I'm going to stop here because this is just a view, but it gives people, hopefully the readers, a little bit of an idea of how we have sort of composed this piecemeal, and there are reasons why we've had to do it, just because of the flexibility that was needed, and how we've organically evolved this into a system, and we feel that we're at the right trade-off.
So you mentioned that Polynote was an open source project, or is an open source project that your group published. To what degree does open source play a role in the platform as a whole, with you as a consumer of external open source projects?
Yeah, so anytime we have to come to a solution after a problem has been identified as worthwhile, we have essentially 4 different options to us, right? 1, we can build it ourselves. 2, we can leverage other platform and engineering organizations within Netflix who are building certain standard platform components. 3, we can go for an open source popular solution set. And 4, we could go for commercial solutions. And our platform does all 4 of those, because you really want to make sure that you are balancing your you're balancing how you're spending your resources and your people's time. There's opportunity costs associated with building everything, whereas you could just buy something. Yeah. But I would say there are certain components that we find that we can provide differentiating value, and we build those ourselves. I would say a lot of this is actually built ourselves, but increasingly we have moved, there have been cases where we have matured and transitioned something away because a better open source solution was available. So we use open source quite a bit for almost all the training frameworks. We are using any and everything out there, from TensorFlow to PyTorch to sklearn to Vocal to anything that you can think of, XGBoost, all of those. But there are certainly also other open source, like large open source systems, distributed systems. Spark is used heavily in some of the distributed feature computation. We have also open source some of the stuff that we have done. As I said, Polynode is one example. And then our container management system that Netflix has open sourced, that's a different team that we use. That's Titus. We use that quite heavily for Dockerizing sort of some of the work that we need to do.
And Netflix is famously an AWS shop. All of the stuff that we saw that runs in AWS?
Everything that you see here runs on AWS. Our entire control plane is on AWS. Of course, our data plane, the actual video, audio bytes come through our Open Connect system, which is our own CDN that we have built. But yeah, by and large, everything that my team does is on AWS. I mean, we keep exploring other options, other public cloud options for here and there, but Amazon and AWS has been a fantastic partner for us. And I mean, ML models will continue to demand more data all the time. And, we have seen an amazing growth in terms of the consumption and the need for resources. And so it's super important for us for that to be elastic and available. And there's been many times that we've run into available capacity in the region that AWS has, but they have been fantastic in continuing to sort of meet our needs. And we've built auto scaling and swim lanes to sort of manage things around.
Yeah.
But it's pretty good to have a good solution for the cloud.
You mentioned that there have been examples where you deprecated an in-house solution in favor of open source that became available to meet the need. That's very difficult to do for many engineering organizations. Is that a part of the Netflix culture that makes that something that you can do versus kind of the not invented here that many organizations struggle with?
I'd say Netflix makes it easy to make those decisions, but it's not something that is unique to Netflix. I think any good engineering organization has to be really true to the principles of where's the best use, most efficient use of the resources they have at hand. And when they realize that some existing solution out there is peer reviewed and thousands of developers have put effort into it, has gotten much better, then we don't want to be living in a fool's paradise of not invented here syndrome. So, there's things that we have built that are relatively small, but a good example is our algorithm teams build a lot of proprietary algorithms for training, some GBDT or gradient boosted decision trees type algorithms. And while some are still in use in certain cases, with the growth and advent of things like XGBoost, which has been very popular, so we've adopted them, and we've migrated pipelines to use those. So that's one example, but there's data systems pieces also that we have certainly embraced.
Awesome. You've spoken a little bit upfront about the some of the varied use cases, the many varied use cases, both broadly at Netflix and that your group focuses on. One of the areas that you work on is the machine learning infrastructure in support of the media recommendations. So personalizing these, the previews and the media that we see when we're looking for movies to watch. Can you talk a little bit about that? Are the challenges there different from the more traditional recommendation systems challenges that you see?
Yeah, it's a fantastic new opportunity for us, and while not entirely unique, it is certainly I'd say we're at the forefront, because so there's two aspects of what you're talking about, right? One is you have a certain set of assets, and you want to figure out, and essentially, which is the best asset that you are going to use for personalizing in a particular context, whether you're coming on a device, a handheld device, or it's on a TV. Are you watching a trailer? Is it part of a gallery page? Is it on sort of the main homepage? And so there's artwork personalization, which I would say is quite similar to the classic recommender system problem, with perhaps one more dimension. In addition to sort of the user item, there's also sort of a candidate of artwork that you could choose from. But the thing that we're beginning to be more excited about is not just the personalization of assets, which so far, let's say, have been selected by editors manually. We're getting into the space of artwork generation or asset generation, where we're using machine learning to enable more productive generation of assets and help editors to find out even more exciting assets and signals within the actual asset files. And so when you're building media ML related infrastructure, some of the things that are different is just the first thing is like the dimension of scale is different. So for instance, when we traditionally think about scale, we're thinking about how many requests per second and how many hundreds of millions of users are going to see this, and what is our latency in inferencing. But when it comes to media, it's sort of different, because you're starting with some raw video footage file or raw assets, and you're trying to come up with other assets generated out of those, or other entities created. So you're not really directly engaging with the members or the end users, but the dimension of scale is still large in that these are gigantic files. We're talking about raw video. You're probably familiar with dealing with some of these, uncompressed original master files. And so just, while the inferencing latency is not as important, but access to what signals you can and embeddings you can derive out of these giant files, and accessing these files, discovering these files, and sort of slicing these files, all of those things is a whole new challenge. And of course, at some level, machine learning has a core that is essentially the same, right? If you're supervised learning, that you need to get some training data, you need to get the labels and the features, put them together, assemble a model, and train it. But even there, the scale dimensionality sort of plays differently. How do you enable that engineering ecosystem around a completely different problem? And so that's some of the fascinating work that my team has been doing for the last year or so, and we continue to expect more stuff there.
And so do you end up with different infrastructure components, different blocks on that diagram for different use cases or different types of problem, or do you try to find abstractions that allow you to operate independent of the type of training data, for example?
Yeah, that's an excellent question, because we wrestle with it all the time. Because what we don't want to do is to build two complete silos.
Right.
And we've spent years building and learning from our mistakes, and sort of perfecting in some ways the systems we've built for our member-facing product ML. So the approach that we've been taking is that there are certain cases where you just have to deal with differently, because the nature of the data is different. And so, for instance, if let's say our feature schema looks like user item, and then sort of some context, some user, some item, and then a list, that won't apply in the context of the input for an asset file that you're trying with. So those schemas would be different by design. But at the same time, we want to sort of replicate the learnings of how we sort of build the underlying fact store, how we build feature abstractions, how we build the transformation layers. So what we're trying to experiment with is we're taking a pass at building it without tight coupling with our existing systems, but using all the abstractions, perhaps maybe in a different language, in a different environment. And then once we have our 1.0 or MVP, we'll iterate back and come and see, what are the common abstractions we can actually share, and how we can start connecting these things at a lower end more. So it's an open question that we are exploring, just because it is a nascent space for us, but it's an excellent one that we wrestle with every day.
Mm-hmm. I got a question in relating to some of the comments you've made around managing performance, latency, throughput, and the idea that you're serving Python natives, with Java APIs? Are there particular things that you do to manage latency and throughput, across those boundaries, or do you allow folks when they need to, if they have a need that gets to a certain level of performance, they have to move over to the lower level APIs?
It's less about the performance that drives it, but more the product context in which the ML is going to be used. So for instance, if you are going to be deploying that machine learning to a member or product user-facing service, you just have to get a certain level of scale. And in that case, we've seen that all of our production services that touch members directly, they are in Java, and we plan to stay that way. But there are what I was talking about was in cases where some of the data scientists and researchers would like to iterate on and propose better models. And so even before it gets to a user-facing experiment, you want to be able to benchmark your existing models on offline data and do offline metric computation. And so latency of computation is less important. What's more important is enabling these data scientists so that they can propose more innovative solutions. And so there we have basically completely abstracted away our Java-based system, and they can completely stay in a Python-centric world. And we do the heavy lifting of sort of mapping, okay, this is, how does that translate into a Spark request that needs to run on, on a distributed cluster, for instance. So yeah, it really depends upon the context in which machine learning is being deployed. And there's no one right solution, right? You have to evaluate whether who are your customers, understanding your customers, and what is the product context in which you're talking about. And it may make sense for you to keep on being in a Python-centric world because you're using ML for decision support, or because you can meet the expected RPS with with hosted solutions that are largely in let's say Python compute environment. Mm-hmm. It won't work at our scale.
Yeah. I was just going to ask, for a lot of platform organizations, the goal is to enable data scientists and researchers, folks that are more on the experimentation side of the spectrum, to get things directly into production through automation. At your scale, is that part of your mandate, or is there this assumption that people are going to throw things over the wall, and engineer is going to take something that's been a research experiment and productize it? How do you think about that?
We used to follow that approach, I'd say 5 or 6 years ago, and thankfully we're no longer following that approach, and we've learned from it. No, there's two ways about doing that, right? You could potentially have a very good alignment between your data scientists and engineers, and they can have high coupling. That's doable in small environments, and perhaps maybe not at large scale. But it breaks very quickly as organizations grow, as well as the scale of your problems grow. And so what we have come to doing is like a core set of engineers or algo engineers who understand the dimensions, who both understand machine learning as well as productizing them, hybrid ML engineers, if you will. And they are the ones who are primarily leading all product-facing experimentation. But what we're doing to enable more data scientists to add to that is doing things like like as I mentioned, we provide APIs that they can benchmark their research, they can reproduce that research, and they don't have to take it all the way to the production, but they can show enough offline metric wins that justifies doing an A/B test. So that's one approach. The second approach is that where the ML platform can help is investing in a lot of guardrails throughout the production deployment pipelines. And so the more guardrails that you can sprinkle, I mean, in many ways, it's analogous, as a software developer, when you're debugging, you are sprinkling breadcrumbs of, hey, here's what's going on. That's one way of monitoring things. In the ML world, when you're trying to deploy things, having these guardrails at different points in time to validate your assumptions on how things are supposed to be gives you the confidence to automate things a lot more freely, because you know that you have some protection, and you won't shoot yourself in the feet. So as an ML platform team, we can invest, and this is one of the learnings that we've had, right? Even now, we find places where there aren't enough guardrails that we would like to have. So if you can invest in building certain guardrails, not just in the offline pipeline, but also in the serving systems, and then tracking feature importances and model drifts over time, all of those things are just good software engineering principles that enable the system to allow research which may, even if it is, let's say, not fully baked into the engineering goodness, there are checks and balances to prevent that from sort of hurting user experience.
Mm-hmm. When you're thinking about those guardrails, how closely do you try to get to the business metric, whatever that is, as opposed to the technical metric?
Ultimately, there are certain key business metrics for all our member-facing experiments. There's ML that's deployed for decision support, as I said, in terms of things like which content to invest in. But our key metrics are ultimately how much engagement were we getting, or whether people are really finding joy. And then we have proxies for measuring joy. How many thumbs up that they're seeing on a particular show, or ultimately, obviously, as a subscription business, retaining members is our core primary metric. And so the metrics that we measure, the primarily is like, are we improving engagement? Are we seeing people are interacting more? And we have fairly decent proxies to those metrics when it comes to both offline and online metrics for the actual experiments that we run. So we feel fairly confident that there is causality there. But ultimately, a metric is a proxy. So you can never be 100% sure.
Right. I want to remind folks to get those questions in via the chat panel. If you're not seeing it, click on the stream tab to go to the stream with the chat panel. One question that came in relates to you spoke about the feature store or the fact store on a couple of occasions. Who are the personas in your organization that are thinking about those facts and making them available and monitoring them? And are they the same? Are they the same folks that think about other aspects of the platform? How do they communicate them to data scientists? And maybe even more broadly, I'm curious how you deal with communication between your team and the teams that you support.
Yeah, no, that's a great question. So there's a fine line between a fact and a feature, but one person's feature is another person's fact, because there are these downstream things that are built. But ultimately, we think of some core facts as things that change rarely, or things that don't change, right? You played a video, you thumbs up a movie or a title, you added something to your My List, or what is some attributes about the content itself. So we have some of these core entities, and sort of over the collective period of experimentation, the ML engineers have identified that these are the facts that are generally invariant, and almost every ML model needs those. And so we basically have identified those as first-class entities, and we have worked with the engineering teams that are responsible for the various microservices involved in generating those facts. And those facts are generated as the homepage is served, as people interact with the Netflix service. And so essentially we log these facts in, and we have a client that works in each of those services, and they can essentially log those facts back to us sort of through our message bus and into our data stores. The identification of new facts happens occasionally, and it comes up when people say it's sort of a new product area that somebody's trying to experiment in, and they need some new facts. And so we work together with the ML researchers. I have a sub team that is responsible for the Axion fact store. And then they identify, they reach out to us saying, hey, we feel that this is a pretty important fact we need. And then we would go to the microservice team figuring out, hey, this is how you're logging, or can you add this login? Here's a client that you can use to log. We do the standard stuff of scaling and setting expectations of how often this would be logged and frequency, which are all part of the APIs for logging. And then we make that available, and then we socialize it through our regular channels, or whether it's our weekly meetings, through our docs, where we talk about, hey, here's something new that's available. It's self-service for people to be able to explore, and we can, and that's where the advantage of sort of an opinionated system comes in, because once you've added it, everybody has immediate access to those facts, and so they can start using it. Even if one team asks for it, the others can use it. And so, yeah, that's how. And you talked a little bit about, you were asking about communication, and the size of the organization determines the mode of how effective communication can be. We have regular opportunities for talking about some of the new facts. There's Slack channels. We announce and broadcast releases and things every so often. So the usual stuff. Occasionally, people realize that, oh, I was doing something on my own, whereas it was sitting in this common fact store. And that's rare now, but it used to be the case. And so, you can always improve the communication.
Elaborating a bit more on the distinction between fact and feature in your architecture, you've got the fact store under Algo Commons. You've got what you call feature abstractions. Are these features built on top of facts, or are they APIs for creating features? Is feature sharing and reusability a big a part of your offering?
Yeah, no, that's a good question, and we've always discussed this internally. And then there's two or three ways in which we do feature sharing. So first off, yes, Algo Commons provides the building blocks, feature encoders, where people can essentially use the building blocks, the data sources and facts coming from, let's say, the fact store, or if that fact is not a first-class entity, and they want it from some unstructured format, they can also access that. But you basically put together a feature encoder, and then you can use Spark or through Boson to compute all of these features for your hundreds of millions of rows. But when it comes to sharing these features, there's a couple of approaches that we've taken. So the most common approach for sharing is through essentially submodels. And so you have, most of the models are essentially ensemble layers, where you have a lot of small models that sort of feed into it. And so some of these features are actually submodels, and they essentially are, they do their scoring and come up with the score, and that score becomes the feature that goes into a subsequent model. So that is very common for doing the sharing. The other approach is the actual definition is shared. So Algo Commons as a library provides a mechanism for promoting certain feature encoders that are available in your standard jar. So anybody who is using Algo Commons sort of has a directory of features that they can just pick from. That is simply the catalog definition of a feature, but not an actual computed value, or as the previous approach does. So those are the two main approaches in use right now. But over time we have come to believe that there are other advantages of actually having a concrete feature store, and certainly in the media ML space that I talked about there. There's some distinct advantages. So we're sort of actually spending some time building one there. But also one key advantage is sometimes the scoring latency is key, where these are large features. You don't need to recompute them all the time, multiple times, especially ones that are not context dependent, and they can be reused. So having a cache of features which are computed relatively recently but can be reused saves you on per scoring latency time, and so that's another motivation why we're investing in sort of building a feature store.
Awesome.
So far, we haven't really had that strong a need. I said the two sharing approaches have served us well. and has been aligned with our loosely coupled setup, because it's basically a submodel and you can just take it. But yeah, I think this is something that we are evolving our stance.
Nice. Speaking of, what are some other opportunities that you see ahead, both specific to the use cases that you serve at Netflix, as well as more broadly in the ML ops, ML operationalization community?
Yeah, I mean, for us, really, there's several new things that that we are investing in, especially when it comes to things like media ML, which is a bit unique to Netflix, but a whole different dimension, as I mentioned. This is about the creative asset generation opportunity, and it can be huge given the amount of investment and that we are putting into original content. And this is really a new space for us. So investing in identifying the right abstractions that will be relevant for infrastructure support of media ML is a big one. The other is leveraging automation more. And across the ML stack, we're certainly using parts of automation in various cases, but embracing auto ML functions more for sort of picking what can be sometimes tedious parts of a researcher's timelines, for instance, selecting the right features or identifying the right neural architectures. That's an area where we intend to invest more in. And then also in the automation of how this research is actually taken to production, and what I call member-facing continuous A/B testing and explore-exploit systems, because then you can do things which are probably not justifiable for a researcher's time, but if they're running in the background with the proper guardrails, then you really can do a lot more, and something in the background can keep on identifying small metric wins, which can accumulate into a big win. So that's an opportunity. And then third, I would say providing more turnkey systems for various ML techniques. So for instance, at Netflix, we use multi-armed bandits and contextual bandits quite a bit, which is an approach to quickly learn an optimal state and start sort of leveraging the winning solutions faster than our typical A/B tests would do. And there's been 2 or 3 different ways in which they have been implemented. This is an example of something I mentioned where, hey, we don't know whether we're going to be investing a lot into it. So we said, okay, let's go ahead and build it in one way. And now there are 3 teams that are doing it in 3 different ways. And here's an opportunity for us to sort of say, okay, you know what, we can standardize here and we can build a turnkey system. So that to me is another area where we plan to invest. And then you can never over invest in your guardrails and how you make sure that because it sort of enables a lot more confidence in how quickly you can take your research to production.
Awesome. Faisal, thanks so much for joining us. Great conversation, and it was wonderful to catch up.
Well, thank you so much for inviting me, and it's always fun to chat with you, Sam.
Thank you.
All right.